These are some of my favorite math stories. In this episode, Mathematics is Psychological. We'll look at some statistics that illustrate some psychological aspects of sports. To put this in context, there have been numerous studies that cast doubt on whether there are players who have great ability in clutch situations late in a close game. There is increasing evidence of streakiness in sports. See the episode on hot hands. But it is not always clear that this is caused by mental states. So finding evidence of the performance of professional athletes being affected by their psyches is rare. In baseball, a hitting streak is the number of consecutive games in which a player gets at least one hit. If a player's chance of getting a hit is the same for each at bat, it is not a difficult calculation to find the probability of a hitting streak. For example, if the player gets a hit 30% of the time, in baseball language bats 300, which is very good, and bats 4 times per game, then the probability of getting a hit in a game is 1 minus 0.7 to the fourth, which is about 0.76. Sounds pretty large, doesn't it? But the probability of getting a hit in 15 straight games would then be 0.76 raised to the 15th power, which is 0.016. So long hitting streaks are rare if the chance of getting a hit is the same in each at-bat, each game. A great 2008 article by Trent McCotter used a different process to predict the number of hitting streaks of different lengths by batters over 50 years of data. He took each player's sequence of hits and outs in a season and then randomly sorted them to get a new season for which he could count hitting streaks. He did this 1,000 times, then compared his averages to the actual number of hitting streaks from 1957 to 2006. If the independence assumption is valid, the simulated streak should match the actual streaks. The accuracy is impressive to a point. For example, the model averages 22,585 streaks of length 5. The actual number was 22,632. However, as the length of the hitting streak increases, the accuracy decreases. The model predicts 7,621 streaks of length 10 or more, and there were 8,410. The model predicts 192 streaks of length 20 or more, and there were 274. The model predicts 7 streaks of length 30 or more, and there were 19. More players keep a long hitting streak going than expected. Well, what's wrong with McCotter's model? His calculations are based on randomizing the sequence of hits and outs. In other words, he is assuming that the order, game, inning, and so on, of at-bats doesn't matter. The assumption that each at-bat is independent of others leads to bad predictions of hitting streaks. Batters are extending hitting streaks beyond what we would expect. McCotter explores several explanations for longer streaks. Streaks of good form and bad form, changes in weather, changes in schedule, and so on. But he finds that the best explanation is a hot hands explanation. Players with a moderately long streak are committed to keeping it going. The longer the streak, the hotter the player, and the more committed the player is to extending the streak. On the other end, the opposing pitcher may feel some pressure to, quote, play fair and give the streaking batter a nice pitch to hit. Evidence of streakiness in McCotter's study comes at the game level. Players had more 3 or 4 hit games and more hitless games than the randomly mixed at-bats predicted. The actual pattern of hits and outs was streakier than a random shuffle of the same outcomes. Evidence of the psychology comes from looking at specific length streaks. In the 50 years of his study, 4 real players had streaks of length exactly 29 games. 4 or more players in McCotter's study had 29 game streaks in about 25% of the shuffles. In the 50 years, 9 real players had streaks of exactly 30 games, and this never happened in any of the 1,000 shuffles. Players were reaching 29 games, fairly close to the frequency predicted by the model, but reached 30 games far more often than expected. Is it fair to say they were highly focused on reaching the round number 30 and then relaxed after reaching 30? Players also had more 20-game hitting streaks than 19 and more 15-game hitting streaks than 14. A record that is often cited as being unbreakable is Joe DiMaggio's 56-game hitting streak. He got at least one hit in 56 straight baseball games. Remarkably, after going hitless in Game 57, he then proceeded to get hits in the next 16 games. The second longest streak ever, by the way, is 45 games, well short of 56. There are many ways to compute the probability of a 56-game hitting streak occurring. In those 56 games, DiMaggio batted .408, hits in 40.8% of his attempts, so the probability of getting at least one hit in 4 at-bats, which is typical for a full game, is .877, and doing this 56 times in a row is .877 raised to the 56th power, which is .0006, less than 1 in 1,500. However, DiMaggio had more than one opportunity to start a 56-game hitting streak that season, and he had other seasons in which he could have started such a streak. On the other hand, he had few stretches of 56 games in which he batted .408. If you reduce .408 to 300, still very high, the probability drops to 1 in 4.7 million. Perhaps the best way of seeing how incredible his streak was is to note that in the 50 years from 1957 to 2006, only 5 players had a streak of 35 games or longer. Nobody reached even 45, but DiMaggio got to 56. The best example I know of showing psychological effects arose when I was doing golf research using a massive data set of golf outcomes. This result had been reported in the excellent book Scorecasting also. Counting every putt on the PGA Tour in 2007, the pros made 88.7% of their birdie putts from 3 to 4 feet. They made 91.9% of their par putts from 3 to 4 feet. That is significantly higher. When asked about this, former touring pro Chip Sullivan said he was not surprised. He said that pros want to make birdie putts, but have to make par putts. To think about this mathematically, be skeptical. Think about a reason that this result could be explained by something other than psychology. If you know golf, you know that if you miss your first putt, you can watch it roll and get information about how your second putt will behave. Sure enough, from a given distance, the pros make a higher percent of second putts, likely for par, than of first putts, possibly for birdie. But if you look at first putts only, the pros still make a higher percentage of par putts than birdie putts from a given distance. You could still argue that a first putt for par usually follows a chip shot from which the pro could gain information about the upcoming putt. However, it is more likely that the explanation comes from the mental aspect of the game, at least in the following sense. A more aggressive mindset, I have to make this, could lead to a more aggressive stroke with a better chance of being successful. Whatever the case, pro golfers are clearly making a higher percentage of putts for par than for birdie. Note that this actually goes against the usual hot hands idea. With hot hands, a great shot to leave a short birdie putt would be more positive than a couple of mediocre shots leading to a par putt of the same distance. In this case, loss aversion is more powerful than positive momentum. There aren't very many examples of studies showing that professional athletes allow their psychological state to affect performance, but it's compelling to search for the various forms of hot hands, clutch play, choking, or loss aversion that might be out there.